Hi, dear students, welcome to my class on atomic structure. This is the most important fundamental of this chemistry topic. In this topic, in this lecture, we are going to learn about the important basics theories of atom, developments of atom, as well as some data information required for the masses and charges of atoms and who discovered electron, proton, neutron, and all these things. So let us start the beginning. In the beginning, we have an important theoretical aspect, that is Dalton's theory of atom is there in this section. Actually, this is the famous scientist named John Dalton developed this famous theory of atom 1803. The main postulate is atom is a hard, is a dense, is the smallest indivisible particle, he told. And told that each element consists of a particular kind of atoms. Another one, he told that different elements are there, means definitely the properties will be different. That means properties of elements changes because differences in kinds of atoms contained in them. So different elements have different atoms are present. Another one is law of chemical combination, which was successfully explained by this theory. That is, the combination of atoms gives molecules. Atom is indestructible. He told atom is indestructible is one of the important postulate delivered by this theory. Cannot be destroyed or created is the meaning of indestructible. Next thing is drawbacks. What are the important drawbacks of this? This theory fails to explain why atoms of different kinds should differ in mass and valency, etc. Another one is isotopes, isobars. The discovery of isotopes and isobars, showing that atoms of different elements may have different atomic masses. Atoms have same element may have different masses. Atoms of different kinds may have same atomic masses. See, different atoms with the same atomic masses are isobars. Different atomic masses with the same atomic numbers are isotopes. So this was a little confusion from Dalton's theory. Dalton's theory don't know about all these things. Next, the discovery of various subatomic particles like X-rays, electrons, protons, etc. during the late 19th century led to an idea that atom was no longer indivisible, which is not indivisible. What he told is not indivisible. We cannot separate the atom, but what the modern theories of 19th century telling, the discovery of electron, proton, neutron, all these things in X-rays saying that atom can be divided. The smallest particle of the matter is not an atom now. But earlier it has given a very good basis for the atomic structure. After that, cathode rays. Discovery of cathode rays in this session we'll see. That is, Sir William Crookes studied various gases in gas discharge tube. That is, discharge tube is nothing but a glass tube with a very high potential applied to its ends. So gas in the discharge tube will be subjected to high potential at low pressures. And the pressure in the tube is lowered to 10 power minus 4 atmosphere. Gas begins to fluorescence glow faintly and established that glow was due to the bombardment of gases by a certain kind of rays emerging from cathode. That means inside the discharge tube, there are some rays are generated, they called cathode rays, which are negatively electrode cathode is there with the travel in a straight line until they strike the anode. And the rays were called cathode rays. So they traveled from cathode to anode. Anode is positively charged end, cathode is negatively charged end. So from this important point, Sir J.J. Thomson demonstrated that cathode rays were deflected onto an electrometer. It acquired negative charge. Also shows that rays were deflected on application of electric field, and the cathode ray beam was deflected away from the negatively charged plate, and these results were found to be identical irrespective of the gas taken in the discharge tube. So cathode rays found to be identical irrespective of the gas taken in the discharge tube. Cathode ray beam was deflected away from the negatively charged plate. And finally, what J.J. Thomson has concluded that cathode rays were a stream of fast moving negatively charged particles called electrons. Actually, the name of electron is given by scientist Stoney, and he also calculated Thomson calculated velocity and specific charge of electron, and the specific charge is nothing but ratio of charge to the mass of the electron, denoted by E by M ratio, that is specific charge. It was found to be same for all the gases told. And this was led to the conclusion that electron must be fundamental and universal particle common to all kinds of atoms. So what is the E by M ratio? That was discovered by scientist is 1.758 into 10 power 11 coulombs per kilogram. Actually, Mr. Mullikan, J. Mullikan determined the value of the charge on an electron with the help of famous oil drop experiment, and has given the charge on the electron is 1.602 into 10 to the power minus 19 coulombs, and the mass of an electron is 9.1 into 10 power minus 31 kilogram. You will study about the oil drop experiments in the physics also, modern physics. Let us study about the positive rays. What are the positive rays? How generated? Let us see. Since the atom as a whole is neutral, it means that an equal amount of positive charged particles should also be there in the atom. Because once the electrons discovered, electrons are negatively charged, which are present in the atom, indicates that atom should not be negative. It is neutral. To balance its charges, what happens? There should be some positively charged particles present. That is the meaning of this study. Goldstein, carefully experimenting with the discharge tube consisting of perforated cathode and showing the presence of another type of rays. And these rays emanating from anode passed through the perfections and the cathode. And these carried positive charge and were called positive or anode rays. Positive rays or anode rays. And here it was established that these rays consist of positively charged particles called protons. And the magnitude of charge on a proton is same as that on an electron, but its mass found to be 1837 times the mass of an electron. The mass of proton is 1.6735 into 10 power minus 27 kilograms. So it is how many times bigger than electron is? 1837 times. You have to remember, that is most important point. It indicates that electron is having a negligible mass compared to proton, and the electron is assumed the whole mass of the atom is associated with the protons, not the electrons. And later on, what happened? Mr. Chadwick has discovered, 1932, Chadwick discovered the neutron as the third fundamental particle from the nuclear reaction, bombarding the beryllium nuclide with the neutron. And the first and second are electron, proton in the fundamentals, and third were discovered. And the mass of the atom after that, they told, is said to be the mass of protons and neutrons taken together. So positive rays discovered by Goldstein, and he told that mass of proton is higher than the electron, so bigger than the electron. So electron mass is almost negligible compared to proton. So that protons are said to be uniting with neutrons in the determination of mass of atom, because both are said to be present at the center of the atom after the recent studies. Now we will start the models of atoms, how the discovery of different kinds of arrangements of atoms there. First we will see Thomson's plum pudding model or watermelon model. And what he telling that together all the facts known that Thomson assumed that an atom is a sphere of positive charges uniformly distributed, and with the electrons scattered points throughout the sphere. And this was known as plum pudding model at that time. However, this idea was dropped due to the success of alpha ray scattering studies by Rutherford and Marson. So Thomson model is ignored that time because Rutherford's model developed. So Thomson's model saying that there are some electrons are there, there are protons are there. The electrostatic force of attraction is present between them, and the fixed positions, these are present, they told. So finally what happened? It was compared to the watermelon, and it was completely failed once the success of alpha ray scattering experiments done by Rutherford and Marson. You'll see Rutherford's model. Rutherford actually studied the scattering of alpha particles, doubly ionized helium atom, by a thin metallic foils of gold and platinum, etc. And he told that narrow pencil beam of fast moving alpha particles were struck on a thin metal foil of 10 power 4 atoms thickness. Finally, what happened? The angular deflections of scattered alpha particles were studied with the help of moving microscope. What are those observations? The most of the alpha particles passed through the foil undeflected and went straight to the foil. The another point here is that some of them were deflected but only small angles. So that experiment is saying there is very small number of particles, deflected. That is 1 out of 20,000 were deflected a large angle of 180. That means they bounce back to their original position. Now, that conclusion is saying that almost as most of the alpha particles are passed undeflected, it was concluded that Rutherford atom must be predominantly empty. So alpha particles were positively charged with appreciable mass of 4 units and were moving high kinetic energy. In order to produce deflections, there must be some enormous positively charged body inside the atom. Okay, what is the meaning of this one is, once the alpha particles moving with high kinetic energy, the deflection is coming means definitely there should be a positively charged body inside the atom, but that was not happened. But very slight deviation happened. The slight deviation where it is happened, that was called as nucleus at that time. So that means only a few received large deflections that led to conclusion that enormous charge must be confined to a very small region, and that small region was given the name nucleus. So nucleus is nothing but the location where the entire mass of the atom is present. Okay, now we'll see the next one, that is Rutherford proposed of that atom is composed of dense positive nucleus thinly surrounded by electrons, and the mass and the positive charge of nucleus are confined in a very small region of space, and that electrons are outside that nucleus, so that the atom is almost entirely empty space. Why? Because electrons are having a negligible mass compared to protons. So almost electron is invisible, we can say, in this assumption. That means once the nucleus is present, around the nucleus electrons are present, and he is telling that this electron around the nucleus is present because electrons are negatively charged and protons are positively charged outside the nucleus electrons, inside the nucleus protons. So there will be an attraction. That means for the stability point of view, electrons cannot be stationary, he told. So if the electron is stationary like Thomson's model, there will be instability and finally electron may fall into the nucleus. Otherwise, they would be drawn into the nucleus. That's why Rutherford assumed that electrons were moving in circles around the nucleus. Circular motion assumption that was introduced by Rutherford at the time to make atom stable, because electron and proton may get attracted if the electron is said to be a static one around the nucleus. So actually electrodynamics, which is telling electron should be revolving, otherwise what will happen? The electron may fall into the nucleus. So the necessary centripetal force being provided by the electrostatic attraction between the nucleus and the electron, that is making the atom stable. So finally Rutherford gave no further justification for this assumption of attraction. Little failed because keep on moving, what will happen? It may also lose its energy. So there is a problem that was faced by Rutherford theory once the electrons discussion came seriously in the study of atom. Note, what are the important experiments here? From these experiments, it is confined that Within the nucleus, the distribution of positive charge is uniform and the atomic nuclei are spherical in shape. That is very clear from these experiments. Later, the discovery of neutrons by Chadwick 1932 established that these also occupy the place in the nucleus bonded along with the protons by very complex type of forces called as nuclear forces. So, what is the force between the electron, between the proton and neutron is nuclear force only, binding energy we can say. Next. Now the constants of nucleus are protons and neutrons. They call nucleons, and the number of nucleons in a particular atom called as mass number denoted by A, capital A, and the number of protons denoted by atomic number denoted by Z. Number of protons are called atomic number. Number of protons is called atomic number. Number of protons plus neutrons collectively known as atomic mass number, capital A is the symbol which is given. Of that, the order of diameter of an atom given as 10 power minus 10 meters means 1 angstrom in it. And the order of the diameter of the nucleus was given as 10 power minus 15 meters is 1 Fermi is given in this from the experiment. So, these fundamental experiments Rutherford is given these ideas. Or the radius of the nucleus of an atom is said to be proportional to the cube root of the mass number of an atom. And the number of nucleons of the atom is nothing but mass number. And R0 is the symbol which is given to the radius of the nucleus. And the radius of the nucleus according to these experiments given as mathematical expression R0 is equals to 1.2 into 10 to the power of minus 15 into a power 1 by 3 meters. So that's why a power 1 by 3 is cube root of mass number. Cube root of mass number is radius of the atom, he told. So these experiments are given wide arrangement about the electrons, protons, neutrons inside the atom. But little failures are there in Rutherford's model. We'll see that the classical theory is telling that electromagnetic theory, charge is subjected to acceleration around the positive charge, opposite charge. Emits the radiation continuously, what happens? Electron in the Rutherford's atom will lose energy, will not be able to stay in a circular path around the nucleus, should ultimately go into the spherical motion. Such an electron will fail into the nucleus, will fall into the nucleus, of course, does not happen. For an electron in an atom, the discrepancy could not be explained at that time. So, atom is stable. When they are saying it is existed, it should not happen. According to Rutherford's model, there are some confusions came because electron may lose the charge, lose the energy, kinetic energies and all. Finally, they may fall into the nucleus. Is a confusion which was drawn from the electromagnetic theory. Later, wonderfully explained by Niels Bohr, a student of Rutherford analyzed atomic spectra of hydrogen atom in terms of quantum theory of radiation and applied to the results of photoelectric effect to it and developed a model of atom which was widely accepted at that time. So Niels Bohr, after studying the failures in Rutherford's model, actually is a student of Rutherford, analyzed atomic spectra of hydrogen atom and in terms of quantum theory and all he developed. Now we are saying Niels Bohr theory is an important one. Why? Because this is the striking aspect of the study of atomic structure at that time. He has taken the Nobel Prize also by giving this theory to the world. And what he studied, we will see. That is Before the study of Niels Bohr theory, we have to know some fundamentals, basics. In this session, nature of characteristics of radiant energy, because we have to go back to some physical concepts. That means characteristics of energy, electromagnetic radiation. Newton was first person to comment on the nature of the light in terms of corpuscular theory of light. According to the corpuscular theory of light, light is a stream of particles commonly known as corpuscles of light. He was able to explain the reflection and refraction. The most common phenomena of light, that is the reflection and refraction. But the other phenomena like diffraction and interference could not be explained by this theory. After Maxwell 1870s proposed that radiant energy light has wave characteristics, and the light according to him is electromagnetic wave arising due to the disturbance created by electric and magnetic fields oscillating perpendicular to each other in space. So corpuscular theory failed to explain some of the light properties of diffraction and diffraction and interference. But Maxwell taken the radiant energy concept of light characteristics is studied and finally succeeded in telling it is having wave character. Particles are having wave character. Like that, all other mechanical waves characterized by velocity c and frequency nu and wavelength lambda. He has given the experiment, the mathematical relation as c is equals to nu lambda, where c is called as constant light velocity 3 into 10 to the power of 8 meter per second. After that, it has become very easy for the scientists to tell about electromagnetic radiation. So what is electromagnetic radiation? Electromagnetic radiation wave is not a single wavelength radiation, but a mixture of various wavelengths or frequencies, that is electromagnetic wave. All the frequencies have same speed, that is c, that is constant. Whenever you are calculating the velocity, the frequency or wavelength, this velocity is constant. If all the components of electromagnetic radiation EMR are arranged in order of decreasing or increasing wavelengths of frequencies, the pattern obtained is known as electromagnetic spectrum. And that we will see is electromagnetic spectrum picture. This is. So, we are observing here cosmic rays, gamma rays, X-rays, UV rays, visible light, and infrared, microwaves, radio waves, and all. Frequency decreasing order, wavelength increasing order given here. This is called as electromagnetic spectrum. After introduced about continuous spectrum, what is continuous spectrum? When sunlight or white light is passed through a prism, it is dispersed or dissolved into continuous spectra of light, means colors. It extends from red 7600 angstrom units at one end to the violet 3800 angstrom units to the other end in this electromagnetic spectrum of visible light. In this region, all the intermediate frequencies between the red and white are present, are known as continuous. This type of spectrum is known as continuous spectrum. Hence, the continuous spectrum is one which contains radiation of all frequencies. Okay, what is the visible light? Visible light, which is passed through a prism, it dispersed or resolved into continuous spectra of colors. So the colors extends from red to violet, whatever we are able to see that one. For this, we have a small example, that is A similar spectrum is produced when rainbow forms in the sky. That is the best example. Now, what about the discontinuous spectrum? Light emitted from atoms heated in a flame or excited electrically gas discharge tube does not contain continuous spread of wavelengths or frequencies. That contains only certain well-defined wavelengths or frequencies, and the spectrum patterns appear as a series of bright lines separated by gaps of darkness, and is called as line spectrum. So discontinuous spectrum is a line spectrum. In this, one notable feature observed is that each element emits characteristic spectrum, suggesting that there is a direct relation between spectrum characteristics and internal atomic structure of atom. Okay. So continuous spectrum, discontinuous spectrum have got different ideas. Continuous means there is no gap. It's a band. Discontinuous means the lines are separated by darkness. Now we will see quantum theory of radiation. This quantum theory of radiation, Max Planck 1901 studied distribution of frequencies of radiations emitted from hot bodies. Actually, he proposed a bold hypothesis that radiant energy such as heat or light is not emitted continuously, is discontinuously in the form of small packets called quanta. So according to quantum theory, the energy is called quanta. And according to Max Planck, energy of the electromagnetic radiation is directly proportional to the frequency of radiation. And the proportionality constant is called Planck's constant if energy of radiation E and the frequency of radiation is nu. Then is given a formula, direct proportionality is there, that is formula is given as E is equals to H nu. E is directly proportional to frequency and H is introduced as constant 6.626 in 10 to the power of minus 34 joule second. If n is the number of quanta of particular frequency, that energy be the total energy TE is given as NH nu. So you want to find the number of quanta, you can use N is equals to total energy by H nu. This is the formula you can use. So these are the main theories we have discussed in this session. Okay, we have discussed about quantum theory in this session. We have discussed about electromagnetic theory, electromagnetic spectrum, that is led to the developments of Bohr's theory, Dalton's theory, Thomson's model, and Rutherford's model in this session. Okay. Hope you have got an idea. This is the basic concepts only. This in this lecture I have taken. We will come back